Hello friends, welcome to the calendering and fiber spinning process under the edges of polymer process engineering. Now these two are again very important processes in the polymer processing. Now before we go into the detail of these two processes, let us have a brief outlook at what we discussed in the previous section. We discussed about the blow molding, different segments of the blow molding, basic theory of blow molding, what are the different application of blow molding. Apart from this, we discussed about the various advantages and disadvantages associated with the blow molding. Apart from this, we discussed about the classification of blow molding, including extrusion blow molding, then injection blow molding, then stretch blow molding, then rotation blow molding. So, all these things we discussed in the previous chapter. Now, in this particular chapter, we are going to discuss the calendering, the arrangement of the calendars or calendar roles in the calendering, how we can arrange, then the factors affecting in the calendering operation. Apart from this, we will discuss about the fiber spinning, like melt fiber spinning, dry fiber spinning, wet fiber spinning, reaction spinning. So, all these things we are going to discuss in this particular chapter. So, let us discuss about the calendering. Now, this particular method is employed to transform the thermoplastic material into the continuous sheets and films, as well as in applying the coating on textile, paper and other supporting material with plastics. So, it is a very common phenomenon. You can see around you there are many products lying which are prepared from the calendering operation. So, the calendering is an alternative to extrusion process with preparing the usual film of 3 or more mils thick. Plastic melt is usually compounded and pressed as it moves to the nip of a sequence of 3 or more heated or highly polished steel rolls to produce sheet or films. Now, here this is the schematic diagram of calendering process for the thin film and the sheet formation. Now, here you see this is the mixer and these are the 2 roll mills where metal detectors and other things are there. Then usually they mix the polymeric material and then it is subjected to the extruder. So, you cannot overlook the importance of an extruder. Then these are the rolls, different rolls where these extruded material is subjected, and these rolls or calendars, they are moving in the designated direction and it is subjected to give the embossing unit. There may be certain embossing or sometimes a watermark and other things you can see. So, these are there and these are the cooling drums, so that the film cannot deform. So, the appropriate cooling temperature is maintained over here and then it trims and gauging and then it rolls over the winding up unit. So, these are the schematic, this is the schematic diagram of the calendering operation. Now, the calendar's goal is to deliver just enough energy to transform a mass of a plastic into film or sheet form without generating enough heat to compromise the material's quality. So, here you see that this is not a very energy extensive process. The only thing is that you have to give a proper melting to the material in the extruder. Rest other things are very simple. Now, it is a crucial factor which needs to take into account, especially when processing stiff PVC. The gap between the first 2 rolls, this one, a web of plastic is produced and the thickness is further decreased by pressing through the second and third nips. Here you see. The spacing between the final set of rolls referred to as a gauging rule, and this determines the sheet's final thickness. Finally, the sheet or film web is then cooled by being pulled around a chilled roll by a takeoff roll, and the web might be rigid or flexible, polished or embossed as the case may be, and the temperature, pressure and rotational speed of the entire roll must be precisely controlled for proper calendering. Using an engraved roll, a design can be produced on the surface as an embossed pattern. Now, plastics with relatively low viscosities, when they melt, they are not good candidate for calendering, right? Because low viscosity may create a problem and some sort of a defects may encounter. So, the processability can be significantly influenced by additives. With this expertise, you can increase the calendar's speed to make them more productive. Additionally, they are better able to handle thicker sheets and produce film and sheets with a tighter thickness tolerance and improved uniformity. Now, this is the actual calendering machine. You see that different rolls are there. Now, to compress the plastic melt into the thin film and or a sheet web construction, very strong forces are applied to the rolls. So, any metal or hard surface material including microscopic particles must be completely removed. Otherwise, on a first instance, they may form an impression over the rolls, and subsequently if keep on going, then it may create the embossed impression over the film or the rolls. So, the rolls will be destroyed by the micron sized metal fragments or a small scratch can destroy. So, the fineness of the product is depend on the surface of these rolls. Of course, the extreme cautions must be exercised throughout the whole calendering process to prevent the contamination of the processing equipment or plastic. Now, continuous prevention, maintenance of these lines, they require a relatively clean operating environment in the facility. So, sometimes the dust and dirt may also create a problem because this may get deposited either over the roll or over the surface of the film what you are producing. This may create deformed product. The bank marks, it is determined to be the amount of plastic that is found in the nip produced between the two rolls. If you recall the previous figure where we mentioned about the nip. The bank markings are roughness on the sheet surface brought on by wrong temperature on bank size. Now, it can be minimized in order to achieve the rolling banks of stock at the calendar nip entrances, behaving in the most orderly manner by optimizing formulation like calendering, speed and the roll temperature. So, all these two factors are very important. Wind up. The complete equipment usually consists of a Banbury mixture followed by heated rolls, chilled rolls and finally a wind up rolls. So, we discussed this thing when we were discussing about the figure. The wind up roll controls the tension on the film and sheeting, so it moves to a calendar rolls. The price per rupee or a pound of film or sheet is less expensive once installed and running constantly than by any other technique including extrusion. It is occurred at the end of the line, and two usual methods for winding into rolls are center core winding and surface batching. In center core winding, one end of the mandrel is fitted into a socket which is power driven, and it requires that uniform sheet or film tension is used or the product will not be uniform in thickness. Let us talk about the trimming. Trimming can be performed either on the calendar or later when the sheet is cold just prior to winding. It is economically sound to trim at the calendar stage where the material owing its existing temperature, this can be readily conveyed back to the calendar feed nip to set the rolls. An extruder feeder for recycle or granular and blended with virgin plastic. The trim material can account for say up to 5% if the width depending on the line's operating efficiency. Now, there are several arrangements of the roll in the calendering operation. Now, the calendars vary in respect to the number of rolls, their arrangements, true length, the conventional inverted length, reverse and fed inverted L, and Z, etc. Now, these large diameter heated rolls have the function to convert the high viscosity plastic melt into film or sheet. There are three rolls. Early in the previous era of calendering, three rolls vertical rubber machines were used. Now, problems developed in processing plastic in the case of feeding horizontal nip, then the gauge variation because of the flexibility in the rubber, then the temperature variation due to the cord rolls used, no capability of for cross axis or roll bending adjustments, roll floating due to the pressure variation in the feed nips. Now, they tend to have the float horizontally. The three roll offset. These rolls were designed to eliminate the major difficulty of the horizontal feed nip. Now, this is, you see, the three rolls. This is the three roll offset. The material drop by gravity into the vertical pass like this, and the offset field nip provides important saving in manpower and yield. The pressure fluctuation of the feed to the other nips are minimized, and this will trend to float vertically. Four rolls, you see different combinations. Four roll inclined Z type, this is the L type, and four roll offset. They are the cross axis and the roll bearing may be fitted, and this compact setup make easily accessible for starting up and operating the machine. Now, these type of arrangements further classified into different types, like four roll inclined Z type, four roll inverted L type like this. This is the inverted L, you see that like this. This is the Z type, four roll offset, and four roll Z type. This one like this. Now, Z type of a roll, this developed in offset roll. Now, here you see the four roll inclined Z like this and four roll Z type. Now, they eliminate the floating of the three roll on the calendering fitted bearing. This is the three. So, each roll can be preloaded on its bearing at the point that is the resultant of the material's pressure and on roll weight. Now, there are various advantages like reduce the height required for the installation of rolls, plant space reduced, reduce building cost. I may have the simple machine construction as they need less compensation for roll bending. They require lower heat loss in the film and sheets, the melt shorter travel, and they operate at a different speed to provide the best performance on the melt. But simultaneously, there are a couple of disadvantages. The limiting the ease of access for roll number 2 here, and 3 in the case of the inverted Z, and with the inclined Z, it is more difficult to feed than the standard type Z because the nip does not hold as much materials. Now, let us talk about the L type roll. Like you see that this is the inverted L type. The compact in construction because more than 2 rolls in the vertical direction, this opposed to the 3 rolls. The rigid PVC manufacturer usually preferred the L type with 4 to 7 rolls being fed from the floor level. Now, flexible PVC is commonly processed using 4 roll inverted L or an F type. Now, universal 5 roll L calendar is used for rigid or flexible PVC film. It provides heat stability and superior film control with a good surface appearance. Now, this system capable the plasticizer saturated vapors to escape via the usual suction hood located above the calendar and filtered before release to atmosphere. There are various factors those who are affecting in the calendering operation. One is the pressure. The high pressure of at least say 6000 psi can bend or deflect the rolls. So, rolls may bend and the smoothness or deformation may occur in the final product. Now this can cause the film, sometimes film or sheets thicker than the middle than the edges. The amount of thrust exerted by the material depends on processing factors like method of feeding stock into the calendar, then the plastic temperature, then the melt flow behavior or required thickness and the width speed of the calendering lines. Other factors, those who are affecting the calendering, is the rheological properties, because ultimately the melting is there, and once the melting is there, you cannot overlook the importance of the rheological aspect. Now this, to compensate the variation in the thickness, requires the surface of the roll to fit a certain profile, that is a crown, and the amount of crown will vary depending on the rheological properties of the plastic material being processed. So the amount of crown is the difference in roll section radius between ends and center, and rolls are crowned, resulting in having a greater diameter in the middle. Sometimes adjustment and the control to the correct distortion is essential, and the crossing of the roll slightly rather than having truly parallel, which results in increasing the nip opening at the both ends of roll. Less deflection at high operating condition can be achieved by the use of stiffer rolls based on the high modulus of elasticity steel or dual steel construction. To bend the roll so that the bending moment is applied to the end of each roll by having a second bearing on each roll neck. Another effect, very important effect, is the temperature effect, because if you go on the higher temperature, viscosity may decrease and the proper shape of the product may not be formed. So the calendar requires the high temperature with a little variation or fluctuation across the roll during the application of a high pressure on the stock. An uneven temperature and pressure along the roll's length could cause the variation in the product thickness. So adjusting roll temperature and speed, which can control the final product dimension. So with cooling rolls, the line permits slower cooling to room temperature, eliminating a shock cooling situation for certain plastic that reduces the physical and mechanical properties of the rigid PVC type material. The embossing roll precedes the cooling rolls, and the film dropped vertically into the embosser with 3 roll, and the temperature accuracy is usually controlled within the range of 1 degree Celsius. So the first calendar's nip needs to be well fused, homogeneous and uniform in temperature. Now the optimum average temperature for food fusion depends upon the formulation. For rigid PVC formulation, this has a typical optimum temperature of 180 to 190 degrees Celsius at the first calendar nip. Another effect which is important, and that is speed effect. The adjusting roll temperature and speed controls the final product dimension. Now roll loads run 1000 to 2000 pounds per linear inches of the soft sheeting and approaches 5000 pounds per linear inches on larger roll for thin rigid material processed cool at 166 degrees Celsius on larger rolls. The speed of the stripper roll must be varied with respect to the calendar speed to eliminate the degree of roll, claiming that the sheet is thinner. The stripper roll speed maintains a constant ratio with the calendar speed. Let's talk about the fiber spinning process. The fiber, it is the material whose length is at least 100 times of its diameter. The synthetic fibers are organic or inorganic material that have been processed into the fiber form or thread lines. They can be categorized as a staple or a short fibers or continuous filament that is very long fiber. So depending on the nature of material, the organic synthetic fiber can be formed in a variety of ways. Now this is the fiber spinning process. The fiber forming process is called the fiber spinning. In this process, the polymer melt or solution is forced or extruded through a small orifice which is called the spinneret or jet. Now here you see, this is the typical synthetic fiber spinning machine. Now this spinneret or jet shaped it into the fiber form, and after this the material undergoes a phase transformation to solid form. So the things are simple. First, the proper application of the heat, the melt, and then it is forced to the spinneret, and then the material is bit cold, that is called the fiber. The fiber forming process is called the fiber spinning, and in this process the polymer melt or solution is forced or extruded through a small orifice which is called the spinner jet. And once this is formed, this is it's shaped into the fiber form, it is wound up to taken up into the bobbin or spool or pin, and thereafter the process fiber is then passed through some other operation to brought it to the final performance level. Now let us talk about the classification of fiber spinning process. Now the fiber spinning process, this can be classified into the different categories like melt spinning, the dry spinning, the wet spinning, the reaction spinning. The selection of particular type of spinning process is related to the material being spun or technique used for solidification. So let us talk about the melt spinning. This is the process of melt spinning. In this process, the molten polymer is extruded. This is the melt spinning. Here you are the polymer chips or granules being faded. Then this is the melting zone, and here is the pool, and this is the metered extrusion. And then this is the spinneret where we are forming the fibers, and then it's cooling, and apart from this the moisture conditioning, then lubrication, just to prevent the agglomeration once it is being rolled out. Then this is the oil dish through which a small quantity of oil being sprayed, then yarn driving, and by this way it goes to the woven for the rolling. Now usually the integral part is that where the molten polymer is extruded in an appropriate medium and it is solidified by the transfer of the heat. Like the polyester yarns and polypropylene and nylons, they are being produced with the help of such kind of a process. This process involves either melting polymer pellets, granules, or pumping molten polymer to spinning units which meters the flow of polymer. The molten polymer passes through a sand or a screen pack, then passes through the spinneret where the fibers are formed, and after extrusion the filament, they are quenched and cooled in some fluid medium such as air or other gases, inert gases or water are taken up. In some cases the fiber is then passed further, then it is drawn separately. Another is the dry spinning process. You see, this is the figure showing the schematic diagram of drying spinning process. This process is again involves the extrusion of polymer solution into a heated gas where solvent is removed and fiber is solidified. So this is the filtered polymer solution. This is the feed, this is the metering extrusion, and this passes through the spinneret and is solidified by the solvent evaporation, and then with the help of air or a lubrication it rolls out to the woven or spindle. Now this particular process involves the polymer usually first dissolved in an appropriate solvent, filtered, and then charged into the device. The spinning solution, the dope, is at higher than the room temperature and above atmospheric pressure before extrusion. So when the dope is extruded, it undergoes a similar process to flash evaporation, except that the solvent vapor is rapidly evolved from the extruded material. After this process of vapor evaluation, the process resembles to conventional drying. Now the wet spinning process, this is the figure represents the wet spinning process. This represents the extrusion of a polymer solution into the liquid chemicals bath, and hence the subsequent solidification takes place by the mass transfer. So here you see the forced circulation of reagent and of water and the cakes, and then there is a drying moment. So all these things are almost similar. Now this process involves the fibers. They are formed by extruding a highly viscous polymer solution through the spinneret into the liquid bath or to solidify it. The solidification is brought by the diffusional interchange between the extruded polymer filament and bath. Now this process is called coagulation. So one or more component from the bath diffuses into the fiber while the solvent leaves the forming filament, and the net result is your solid fiber. In case of viscous rayon, the chemical reaction superimposed on the diffusional process. Now in other words, or only diffusional process will be considered. So in wet process, the temperature effects and heat transfer play a very small role than in the other two principal spinning processes. Let us talk about the reaction spinning process. In this process, the partially reacted material, that is pre-polymer, it is referred as a pre-polymer. So the pre-polymer is extruded into the heated fluid medium. So where solidification takes place by chemical reaction, and generally the reaction spinning is resembled either dry or wet spinning process. For example, the creatures like spiders, silkworms, antlans ejects or spin a pre-polymer which then reacts and form the final polymeric material. Now here is the comparison between the spinning types. So we have enlisted all four spinning process which we discussed in the previous slides. Like melt, this is the type of the phase transformation and the materials what spun. The melt, the solidification of molten masses. You can spin the material like nylon, polyester, polypropylene, glass fibers, etc. Then the dry, that is evaporation of the solvent with the solidification, then cellulose acetate, cellulose triacetate, and polyacrylonitrile. You can process. Then wet, the counter current diffusion in a bath with solidification, and you can process the polyacrylonitrile. And the reaction, the material reacts and solidifies. This is the phase which of transformation. Now what is the fiber requirement and spinnability? The synthetic fiber must have certain characteristics in order to be useful material. They should have high thermal softening point to permit processing or ironing, a high initial modulus of elasticity or stiffness, the reasonable tensile strength over a wide temperature range. The tensile strength of fiber can be defined in denier. It is the measure of the size of a fiber and defined as a weight in grams of say 9,000 meter of a fiber length. Denier is proportional to both the density and the cross sectional area of the fiber. So the larger the denier, the greater is the cross sectional area of the fiber. Now here you see the properties range for the synthetic fiber. Now properties, the tensile strength gram per denier. This textile application must be 5, and for an industrial application it should be in between 7 to 8. Then initial modulus, that is again gram per denier, it should be for the textile application it should be 30 to 60 and 50 to 80 when we talk about the industrial application. Then elongation at breadth, it should be less than 10% for the textile application, and it should be in between 8 to 15% in the industrial application. And the temperatures, creep or softening point, at least 215 for the textile application and 250 for the industrial application. Other properties like good abrasion and moisture resistance and the chemical resistance should be there. Now let's talk about the spinnability of the synthetic fiber. A polymer is said to be spinnable if it is chemically and thermally stable under the spinning conditions, capable of yielding continuous fluid or semi-solid fibers, easily transformed into the solid polymers. Now there is a spinnability limit Now, if the viscosity of the spinning fluid is too low, that is a melt temperature is too high or solution too dilute, the fluid will be extruded in individual drops. Extreme of high viscosity can lead to the cohesive fracture of spinning fiber. The measurement of spinability, it is the maximum thread length which appears to be complex function of viscosity and velocity. Now, the overall spinability, they are set by two end condition: cohesive brittle fracture caused by the applied tensile force and a spontaneous development of the surface waves with the resulting breakup into drops. So, in this particular chapter, we discussed about the fiber spinning and calendering. Both are very crucial operation in the polymer processing. And for your convenience, we have enlisted different references which can be useful if you require further studies. Thank you very much.